Hey there, Year 12. Today's maintaining a balanced dot points are 9.2.1.9, identify some responses of plants to temperature change, and 9.2.3.9, describe adaptations of a range of terrestrial Australian plants that assist in minimising water loss. So we've popped two dot points together. They are from different sections of the syllabus, but they do kind of go hand in hand, okay? So the first one we're looking at is identifying some responses of plants to temperature change. So when we identify it, we just need to be able to recognise the response and name it, okay? What they do. For the next one, we need to be able to describe adaptations, so give characteristics and features of adaptations of a range of terrestrial Australian plants that assist in minimising water loss. Okay, so just a bit of background information that helps with this. Plants can lose water through a process called transpiration. Okay, so we have done that a little bit. But I'm going to just explain it again to refresh your memories. So we know plants can't actually move around when it gets too hot or too cold, okay? They can't go and find some shelter in cold weather, and they can't go and find a spot in the shade when it's really sunny, because generally they are the shade, okay? So they have to have other responses and adaptations to help them cope with these temperatures, okay? So transpiration is basically water evaporating into the atmosphere from leaves of a plant, okay? And it happens through stomates, okay? So it has two functions: to help cool the plant and also to help pump water and minerals into the leaves through photosynthesis, okay? So because water molecules really like each other, they like to stick together, okay? Because of a thing called hydrogen bonding, okay? So the molecules all want to stick together. So when one water molecule evaporates out of the leaves, because they like each other so much, it pulls another one up into its place, okay? And then that pulls one up and the next one up and the next one up, and then that goes all the way along the plant through the roots. So that helps it pull water in through the roots, okay? And that's what we call a transpiration stream. So there's a few different responses of plants to temperature change, heaps and heaps and heaps of different types, okay? I've done a couple of specific ones and I've done a couple of general ones. So Australian boab trees, which is this tree down the bottom here, oh, what have I done? They lose their leaves in hot summer months, okay? So that helps them lessen their exposure to leaves in high temperatures. That's an advantage because generally, as we just said, water gets lost through transpiration through the stomates, okay, which are mostly on leaves. If they get rid of their leaves, there's no stomates for the water to be lost through, okay? There is a few still on the stems and things like that, but in general, a lot less area for water to be being lost through evaporation. Many plants also use evaporative cooling, so that's evaporating the water from the leaves through the transpiration process that we just looked at. So that helps cool the plant, which is great, but there is also a downside in that if it's hot weather and they're evaporating a lot of water, they're also losing water, and it tends to be when there's not a lot of water around. So only some plants use that process. Others it's a real disadvantage to because it just means that they're losing water. So eucalyptus trees have a bit of a response in that they are actually able to open and close their stomates. So they can close them during the hottest part of the day so that they can reduce water loss. So the stomates only are open in the early hours of the morning and the late hours of the afternoon when it's cooler. So they can still photosynthesize because remember the stomates also allow gas exchange for the plant so that they can carry out photosynthesis. So they can still carry out photosynthesis, still keep alive, but they're losing less water through this transpiration, like I said, they don't have control over it, so it is sometimes a disadvantage to plants because they don't want to lose that much water. Many plants also lose any above ground parts, okay? So all the bit of the plant above the ground will die off during winter time, and this bulb still survives underneath the ground, but it's protected from the cold weather in the warmer soil. So that provides a bit of a protection, and that's in response to cold weather rather than warm weather. So that's the first dot point, okay? Some responses of plants to temperature change. The second thing we need to look at are the adaptations of plants, okay? So I've popped it up in a little table. We've got the name of the plant as well as its feature, a bit of a diagram, and how it helps minimise water loss. This is particularly important in Australian plants, and remember we do have to look at Australian plants in particular because Australia is a very dry country overall. So plants need to be able to minimise water loss because they need to hang on to what they've got while they've got it because they don't know when they're going to get some more water again. So eucalyptus leaves have what we call a waxy cuticle. So it's this waxy covering on the top of the leaves. And because it's waxy, we know wax is a type of oil, and we know oil and water don't mix. So that means that it blocks water moving out of the leaf. So that waxy cuticle means less water is lost through transpiration, through evaporation through the leaves. They get to protect it and lose a lot less water. So it keeps water in the plant. Spinifex grass has leaves where they can coil around each other towards the underside. That helps minimise water loss because stomates under the leaf are protected, okay? So they're protected from the direct sunlight, they're protected from wind, which can speed up evaporation, and so transpiration is reduced. So the plant is losing much less water because of that. The grassleaf hakea have really long and really thin leaves. That's so that there's a reduced surface area facing the sun. If there's less surface area facing the sun, the plant doesn't get as hot, which means that it doesn't evaporate as much water through transpiration. So you can see that transpiration is an essential process. It does help sometimes plants with enough water to help cool themselves, but in most Australian plants we need to try and avoid transpiration because they really need to hang on to the water access that they have. Pigface is a type of plant that has really big, thick, succulent leaves, and that helps minimise water loss because there's a really big area to be able to store water in, okay? So they don't lose as much water, or they still have a ready water supply because these leaves are thick and have so much storage. Acacias have really extensive root systems under the ground with root nodules, and that allows them to absorb water a lot more when it's available. So not so much minimising water loss, but helping them gain as much access to water as possible. And the oleander is very similar. So it has a deep root system below the water table, which lets it tap into the water table, all that water flowing underneath the soil, even if the surface is dry. So that's our dot points for today. Enjoy.